Okay, welcome along to the Spring Further Maths mock paper walkthrough. So I'll go through the full paper in this video. It might be quite a long video, but of course you can just skip the questions that you got wrong or the ones that you want to go through again. I'll try and go through the paper in a bit of detail, really kind of explaining what I'm thinking and kind of as much as I can the understanding behind the questions. So hopefully that's going to be useful. Of course, it will be quite a long video. You don't need to watch the whole thing, but you can really just focus in on the questions that you got wrong. But of course, if you want to watch the full thing, you're welcome to. I would really appreciate it if you could maybe give the video a like at the end if you thought it was useful. Any comments, of course, I would always try and reply to them, and keep spreading the channel. That would be massively appreciated by me. Anyway, let's get into it. So you guys know because you've done the paper, but the paper consisted of matrices, differentiation, polynomial division, and the binomial expansion. And the paper is out of 50 marks. I think that is wrong, one of the students told me, but ignore that and good luck. And let's begin with question 1, which is looking at multiplying matrices. Now to do this, to multiply matrices, I've got my pen in the right thickness. Let's double check it. Good. Now what you can see here is you've got a 2 by 2 matrix multiplied by a 2 by 2 matrix. That's going to give us a resulting 2 by 2 matrix. Now I'm going to just draw a big bracket over here. Now the way that you do this, I'm going to show my highlighter, is we're going to multiply the rows with the columns. So to get the top left number here, I do the 5 times 2, which is 10, and I add on to this the other numbers in the columns and rows, so the negative 3 times negative 1, which is positive 3. So I'm just adding on 3. Good. I then do the first row, but this time with the second column. So I'm keeping it with the first row, but now to the second column. And I go and do 5 times by negative 3, which is minus 15. And to this, I add on negative 3 times by 5, so I'm adding on minus 15, so minus 15 again over there. That's good. And then, so I've done the first row with the first column and the first row with the second column. I now do the second row with the first column in the same sort of fashion. So I go and do the 1 times by 2, which is 2. And I go and take the other numbers, so this 2 times by the negative 2, which is minus 2. So I'm adding on minus 2, which just means minus 2. I then do the second row again, but with the second column this time, and doing it in the same fashion. So 1 times negative 3 is minus 3. And then to this, I'm adding on 2 times 5, which is positive 10. And then from here, I've just got to go and collect up all of the numbers. So 10 plus 3 is 13. Minus 15 take away 15 is minus 30. 2 take away 2 is 0. And minus 3 out of 10 gives you positive 7. So 13 minus 30, 0, 7. This is the first answer, the 2 marks in the bank. I'm just going to double check I'm recording because that would be a bit of a shame. I am recording. Perfect. Right, number 2. Now, if you look at this and you think, oh, a bit confusing, I've got different variables in here, a squared, I've got b, I've got all of this stuff here. Don't let that scare you. Just approach it how you could approach it, right? Which is to consider looking at multiplying the first 2 matrices. Ignore this bit for the time being. Let's just multiply this 2 by 2 matrix with this 2 by 1 matrix. Okay. Now, if you multiply a 2 by 2, so this means a 2 by 2, 2 rows and 2 columns, with a 2 by 1 matrix. Okay, this has got 2 rows and 1 column. The resulting product is you're going to be getting a 2 by 1 matrix. Okay, so let's go and do this down here. Make up a bit of a matrix down here. In the same way as last time, I do the first row with the first column. I'm going to go and do it in yellow actually to keep it consistent. So the first row with the first column. 7 times 2 is 14. And to this, I'm going to be adding on the a squared times a, which is a cubed. There we go. This is the first number of the 2 by 1 matrix. Now, because a cubed and 14, they're not like terms, you can't combine them. Okay, but this is just effectively one number. I then do, on the bottom, the second row with the first column. So I go and do b times 2, which is 2b. Then I go and do the negative 5 times by a, which is minus 5a. Okay. Now I can't Sorry, so it's 2b add minus 5a, which is just 2b minus 5a, of course. So this matrix multiplication gives me this here. And I know that this is equal to this matrix. So this is all equal to the matrix 78, 12. Now really what I can go and do here is I can just go and compare each part of the matrix. So the top number, 14 plus a cubed, must be equal to 78 because they're equal. So the top of the matrix must be equal to this number 78. So I'm going to highlight this and say, well, this must be equal to 78. So you're going to get an equation because we've got 14 plus a cubed is equal to 78. If I go and take away this 14 onto this side, that's going to give me a cubed is equal to 78 take away 14, which is going to be 64, and then perfect, right? If we go and cube root both sides, which is the opposite of cubing, well, the cube root of 64 gives you a nice number, which is 4. So a is going to be equal to 4, which is good. I'm now going to go and work out b by doing a very similar thing to what I've just done. Let's go and compare the bottom number, the 2b minus 5a, that must be equal to 12. So we can form another equation here. So I've got 2b minus 5a, and I now know that a is equal to 4, so I can replace the a with 4, and that must be equal to 12. So 2b minus 20 must be equal to 12. Let's go and add on this minus 20 to this side. So 2b must be equal to 32, and then divide by 2, so b must be equal to 16, and that is your final answer. Okay, so a is 4, and b is equal to, I'm checking the mark scheme, sorry, the mark scheme's not very clear to read. B is 16. Okay, I'm just going to double check that, but it should be absolutely 100% fine, but of course I don't want to make any mistakes for the video. There we go, perfect. A is 4, B is 16, perfect. So another 3 marks in the bank. There we go. Question number 3. Now, matrix transformations I think is one of the trickiest parts of the course. Now, truthfully, probably quite a good thing to do before you sit the exam is just to memorize all of the matrix transformations, which you can see on screen, hopefully, if it comes on. Oh, it's not seeming to appear there. Let's try again. No, that's not what I want. Sorry, guys. Let's get rid of this. Sorry, guys. I've got a screenshot of the. That's weird. Why can't I get that on screen? Just give me 1 second, guys. I've just got. I want to get the matrix transformations on screen, just so it would make it a little bit clearer for you guys. I thought I had it ready, but it seems to not be quite working. But give me a second. Add to library. Bear with me, guys. Apologies for this technical difficulty, but we should be good soon. Let's get this up, and hopefully, that's weird. That's really weird. Okay, here we go. Right, it is here. I think it was just going. Guys, give me apologies for that slight delay. That's a little bit annoying. And let's bring this down. Right, so what I recommend you do before you, well, if you can memorize them now, the better, the sooner the better, really. These are all of the matrix transformations that you guys need to know. So if I ask you this kind of question, right, the matrix M represents a reflection in the line y equals negative x, write down the matrix M. If you just know off by heart that if you reflect in the line y equals minus x, and that gives you, and that's going to be the matrix 0, minus 1, minus 1, 0, it does make your life a lot easier. Okay, so I'm going to put it in here. So the answer is 0, minus 1, minus 1 is 0. Okay, that is what this is the matrix that describes a reflection y equals minus x. Now, if you didn't know that, you can actually prove it yourself. Now, I'm going to just show you one time how you can prove a matrix transformation using the unit square. I always like to understand where things come from, and I think it's useful that if you do forget these in the exam, you can draw upon something to remember them. I'm going to show you this one time, But truthfully, you want to probably memorize these because it just makes things much quicker in the exam. Okay, but if you did forget that this is the matrix that you wanted to, what I would always go and do is consider the identity matrix, which is given by the matrix 1, 0, 0, 1, and effectively you can think about these as being x and y coordinates. So this is a coordinate 1, 0. This is going to be another coordinate x and y over here. So you've got two coordinates. You've got the coordinate 1, 0 here, and you've got the coordinate 0, 1 as the other one. Now the unit square is this thing down here. It is a square from the origin, which goes 1 across to here. It goes up by 1, and it goes across by 1 like this. So I'm doing a different colour. So it goes from the centre across by 1, up by 1, across by 1, and then down by 1. Now these coordinates will be on the unit square. 1, 0 is going to be this point here, of course. So this is the point. I'm going to do it in green. 1, 0. And the point 0, 1, this one, is going to be up here. Now, if you were to reflect this unit square in the line y equals minus x, well, that line, y equals minus x, looks a little bit, or it does look like this. It's a diagonal line that goes through the centre like this. If you consider what happens to each of these coordinates, for example, 1, 0, which is here, well, 1, 0 would go down to here and then here, wouldn't it, if you reflected it? So it would go down to this point here. And this is going to be the coordinate 0, 1. I'm going to do it in green, sorry. This would be the coordinate 0, 1. So the point 1, 0 would go to, 0, minus 1. And then this coordinate, which is 0, 1, which is up here. If you reflected this in this mirror line, it would go across and then down, it would go down here. And this is the coordinate minus 1, 0. So it would go to minus 1, 0. So what's happened is this 1, 0, okay, has gone to 0, minus 1, which is this part here. So this has gone from this, and then once you reflect it in y equals minus x, it goes to this, 0, minus 1, as you can see here. And this coordinate, 0, 1, this one, once reflected, went to minus 1, 0, which is what you can see here. So you can consider how the coordinate this changes after the transformation to this, and then this one to this. I think it's a really nice way to look at it. It is a bit consuming. Like for a 1-mark question, you don't really want to be doing this in the exam, but that's the understanding behind matrix transformations, and it works for all of the other transformations. Okay? Right, number 4. This one is another matrix transformation question, and it says, describe geometrically the single transformation represented by n squared. Well, let's first of all work out what n squared is going to be equal to. That's going to be, what n squared is going to be taking 0, 1, minus 1 is 0, and multiplying it by itself. So 0, 1, minus 1 is 0. And let's work through this the same way as before. Okay, so we're going to take the first row and the first column and multiply. So 0 times 0 is 0, add 1 times by minus 1 is add minus 1, so just minus 1. I then do the first row with the second column. 0 times 1 is 0, 1 times 0 is 0, so that's just going to go to 0 plus 0, which is 0. I then do the second row with the first column. So negative 1 times 0 is 0, and 0 times by negative 1 is 0. Add them, we get 0. We've then got the second row with the second column. We go and do negative 1 times by 1, which is minus 1. And we add to this 0, add 0, which is just 0. So overall, this will go to 0 minus 1 is minus 1, 0, 0, minus 1. Okay, so then once you've got this here, it's now just about identifying, right, what does this matrix represent? And again, if you've memorized these here, okay, let's go and zoom this out a little bit. If you memorize these, you'll know, right, it's just about identifying, well, which one of these here does this represent? Minus 1, 0, 0, minus 1 is this one here, which is a rotation 180 degrees about the origin. Okay, so let's go and write this up. So this represents a rotation 180 degrees about the origin, and that's it. So if you know the matrices transformations off by heart, it just makes your life a little bit easier. Instead of kind of going with that unit square and deriving stuff, it just takes a little bit of time. But that's the answer. Question number 5, a 4-marker, says this. A, B, and C are transformations in the XY plane, and this actually is going to be a useful thing to have, I'm assuming. I'm going to bring this down again. And the question says this. Use matrix multiplication to show that C is equivalent to a single reflection. Okay, so you've got A followed by B, and then C says it's a transformation A followed by B. So what you're really saying is A and B is the same thing as just doing C straight away, and it's saying show that C is a single reflection. So it's going to be one of these ones over here. Now again, if you just know off by heart that a rotation about 90 degrees anti-clockwise is this matrix, that's going to make your life a lot easier. So let's just go and define it, that A is going to be equal to this one here, which is -1, 0, 0, -1, and then B, which is a reflection in the x-axis. If you just know off by heart that that is this matrix, 1, 0, 0, -1, okay, 1, 0, 0, -1. If you combine matrix transformation, so you've got A, then you follow it by B, what you actually have to go and do to get the matrix that you want is you multiply them in the reverse order. So you've actually got to go and do B multiplied by A. So this means B times A, and that gives you this here. And I went through this on a previous video on my playlist, but just know that if you've got A followed by B, to get the transformation, you multiply them in the reverse order. Let's go and do that. Let's go and take B, which is 1, 0, 0, -1, and let's multiply it by matrix A, which is -1, 0, 0, -1. Okay, if we go and do this, that's going to give us the following. Again, first row with the first column. Let's go and do it in yellow to keep it consistent. So let's go and do the first row with the first column. So 1 by -1 is -1. And then 0 by 0 is +0. I've then got the first row with the second column. So 1 by 0 is 0. 0 by 0 is 0. Add them, we just get 0. We've then got the second row with the first column. So I've got 0 by -1 is 0. That gives you 0 again, so just 0. And then I've got the second row with the second column. So I've got 0 by... Ooh, that's not what I wanted to do. I've then got 0 by 0, which is 0. -1 by -1 is actually +1. So this is going to go to -1, 0, 0, 1. And hopefully that's going to be on here somewhere. There we go. So there you go. It is a reflection in... have I made a mistake here? 1, 0, 0, -1. Guys, I'm really sorry. I made... sorry, looking at the there's a mistake here, isn't there? Right, I've written down A wrong. Rotation 90 degrees anti-clockwise, apologies guys, is this one here. And I've written the one above. No, which one have I written? I've written, sillily, this, I've written the wrong one. I've written, I don't know what I've written, but it's wrong. Apologies, right. A, sorry guys, should have been, A should have been 90 degrees anti-clockwise, should have been this one, which is 0, minus 1, 1, 0. Apologies guys, so if I get rid of all of this now, I'm not going to record the video guys, just because it takes a little bit of time. Apologies, but we should be fine. So B times A, I should have been writing 1, 0, 0 minus 1, times that by A, which is 0, minus 1, 1, 0. And this will give me the matrix 0, minus 1, minus 1, 0, working through it in the same way as before. And this matrix refers to the matrix over here, which is a reflection in the line y equals minus x. So what I've shown is if I multiply B with A, these two together, I get the single transformation, which is this one. And I've just got to go and state this down below, that this is a reflection in the line y equals to minus x. Guys, apologies about that, but it should be fine. There we go. Right, number 6, moving on to differentiation. Lovely. Now, if you want to find the derivative dy by dx of anything at this level, you've got to have it as just a, there can't be a denominator. There can't be a variable, in this case x, on the denominator. You've got to get rid of that. Now, to do this here is quite simple. All I've got to go and do is rewrite this fraction as 4x cubed divided by x to the 4 and add on x to the 7 divided by x to the 4. I've just broken up this singular fraction into two parts, okay? Because if you put this together again, you would go back to this. Now, if I consider this, it becomes quite nice, because if I look at the x parts, well, x cubed divided by x to the 4, laws of indices will be x to the minus 1. So it's going to be 4x to the power of minus 1. And then I've got plus this bit here, x7 divided by x4, take away the powers, will give me x cubed. Now this is still just y equals to, I've not differentiated anything, I've just rewritten this as this, and now I've just got a singular, I've got no denominator here, I can just now begin to differentiate this. So dy by dx is going to be equal to, now we take the power minus 1, I times it by the 4, give me minus 4x, and I reduce the power by 1 to give me minus 2. And then I consider the second term, which is x cubed. I take the 3, I times it by the 1 in front of the x. So 3 times 1 is just plus 3x. I reduce the power by 1 to 2. So dy by dx is minus 4x to minus 2, add 3x squared. And this is the answer, guys. Okay, so if you knew how to kind of break this up, it becomes quite an easy question. Good. Question number 7 is the following. Let's have a look. Looks like a nice one. And we've got this. The equation of a curve is given by this, where k is a number, that's what a constant means. When x is 2, the rate of change, right, and the rate of change we know is dy by dx, is 23. What this means, what it is saying is the rate of change when x is equal to 2 is equal to 23. That's what this means. So what it's asking me to go and do is to differentiate this equation. Let's go and do that first of all. Let's go and find dy by dx using the same law as last time. I take the power of the first term, 4, I times it by the 1 in front of the x. So 4x, reduce the power by 1 to cubed. The second term, right, 3k is just a number. Okay, that's all, don't let that k confuse you. And I apply the same rule. I take the 2, I times it by the minus 3k, which will give me minus 6k. X, reduce the power by 1, just a 1, or just the same thing as writing x, isn't it? So that's it. So what the question is saying is, if I substitute in x is 2 into dy by dx, it's going to be equal to 23. Let's go and do that. Okay, so 4, and then x is going to be 2, and I can cube it minus 6k multiplied by x is 2 is going to be equal to 23. So 2 cubed is 8, and 8 times 4 is 32. So 32 minus, I've then got 6 times 2 is minus 12. So minus 12k is equal to 23. And now I've got a simple linear equation where I'm trying to find k. I can get the 32 onto this side by taking it away. So minus 12k is going to be equal to 23. Take away 32, which is minus 9. So minus 9. To get k on its own, we're going to go and divide by minus 12. So we're going to get minus 9 divided by minus 12. Or the two negatives will give a positive answer. If you divide by two negatives, you get a positive. And 9 over 12 is the same thing as 3/4. So k should be equal to 3 over 4. So 3/4, or of course you'd write it as 0.75. And that is the answer, guys. Okay. Question number 8. Beautiful question. Okay, I think it's a 5 marker, this one. And it says the following. The equation of a curve is given by this. Work out the stationary points. Now, the stationary points, all that means is on a curve, okay, the stationary points are where the gradient is 0. So that's a stationary point, and that there would be a stationary point. And where the gradient is 0 is where dy by dx is equal to 0, because dy by dx gives you the gradient, and when it's 0, you get these flat points here. Now, this point up here you call a local maximum point, and this point here you call it a local minimum point. To determine the nature of the points, okay, you've got to understand, or you've got to use the fact that the second derivative, if this second derivative, d2y by dx squared, is bigger than 0, you're going to have a minimum point, and if the second derivative, d2y by dx squared, is less than 0, you're going to have a maximum point, whatever that means, but you're going to see in a second. But first of all, to get the stationary points, you've got to go and differentiate this first and go and put it equal to 0. Let's go and do that. So let's go and first of all go and do dy by dx. Using the power law, we're going to be getting 3x reduced the power by 1 to 2 minus 6x reduced the power by 1 to 1, and that's it. Now we've just said that the stationary points is when this is equal to 0. Put this here equal to 0. So we're going to be getting 3x squared minus 6x is equal to 0. Now to get the value of x's here, we're going to factorize this part of the equation. And this is a simple, just grade 3 from GCSE maths expression we can factorize. We can take out a 3, we can take out an x, open a single bracket, and we can get this and put it equal to 0. Now the 2x values are going to be either when 3x is equal to 0, which is where x will be equal to 0, or where x minus 2 will be equal to 0. Therefore, x must be equal to positive 2. So the two x coordinates of the stationary points are going to be x is 0 and x is equal to so I'm just getting the marks up so I know that I'm not making any silly mistakes. X is 0 and x is 2. So these are the two x coordinates. Now to get the y coordinates, you've got to put the x values into the original curve, which is y up here. So when x is 0, we're going to go and put it into this up here. We're going to put a bit of a divide in here. So when x is 0, we're going to be getting y is equal to x cubed, so 0 cubed minus 3 times 0 squared at 5, which is just going to give you 5. So when x is 0, y is equal to 5. And when x is 2, again, you put it into the original curve to get the y coordinate. This one's going to be a bit more working, but nothing we can't handle. So y is equal to x cubed. So 2 cubed minus 3 times 2 squared at 5. So y is equal to 2 cubed is 8. 2 squared is 4 times by 3. Minus 3 is minus 12. Adds 5. That's going to give you minus 4. Add 5 gives you positive 1. So 1 is going to be the y coordinate. So what you've gone and done is, and this is just a sketch, so just to kind of make a bit of a visual representation here, you've got the coordinates of this point, that could be 0, 5, and this point could be 2, 1. Now, it could be the other way around because I'm not sure which way the max and minimum points are, but that's what you've done so far. You found the coordinates where the gradient is 0, so the kind of the maximum and the minimum points. Now, this is the part that tells you whether they're maximum or minimum. So nature is whether they are maximum or minimum. That's what nature means. Now, to consider this, we've got to consider the second derivative, d2y by dx squared. Okay. Now, if I go and differentiate this again using the same law, 2 times 3 is 6x reduced to the power by 1. We get this, and then this will go to just minus 6. That is the second derivative. Now, I've got to go and put in the x values, so 0 and 2, into this, and then if they're bigger than 0, it's minimum, less than 0, maximum. Let's go and do this one. So d2y by dx squared, let's first consider when x is equal to 0, we're going to get 6 times 0 minus 6, which is minus 6, which is less than 0. And because this is less than 0, this point is a maximum point. So 0, 5 is a maximum point. Okay, there we go. And I'll do the same thing. I consider the second derivative because that tells you the nature of the stationary points, but this time when x is equal to 2. And it will be the case, this will be bigger than 0, but we'll just work through it. So 6 times by 2 minus 6 gives you positive 6, which is bigger than 0. And because it's bigger than 0, this point is going to be a minimum point. So the nature is going to be a local minimum. And that's it. Now, when you first see this, it might seem really complicated, but actually this is a really generic question on the topic. And actually, once you do a few of them, it's actually pretty easy, really. It's just differentiating, a bit of substitution, but it does take a bit of time to understand it. But that is the question, guys. Okay, you can do this stuff. Right, question number 9. Looking now at polynomial division. Let's take a look. We've got this question here. 3x minus 7 is a factor of this polynomial. Work out the other two linear factors. Now, to do this, we've got to go and do a bit of polynomial division. So I've got 3x minus 7, and we're going to be dividing this into this thing here. So 3x cubed minus 4x squared minus 13x add 14. So the way that we work through this, 3x times what is 3x cubed is going to be x squared. And let's just double check it, because hopefully 3x times by x squared does give you 3x cubed. Good. I then take the minus 7 and times it by this, which gives me minus 7x squared. And now I perform a subtraction. I go and take away these two things. Now these should always cancel out to give you 0. They do. Minus 4 minus minus 7 is minus 4 add 7, which is positive 3x squared. And I then bring down this minus 13x over here. So I bring it down over here. And then to get the next part up here, I think, well, 3x times by what gives me 3x squared. It's just positive 1x, so plus x. Let's double check it. 3x times by x gives me 3x squared. I then take the second part here, the minus 7, and times it by x, which gives me minus 7 and then x. And again, I perform a second subtraction. I take these away. That will give me 0, and minus 13 minus minus 7 will give me negative 5x. Okay, because what I'm doing is I'm doing minus 13. That goes to add 7, which is not minus 5, minus 6. Guys, apologies. Minus 6x. There we go. And I bring down this 14 over here. So plus 14. And then I go and do 3x times by something is minus 6x, but it must be minus 2 over here. 3x times by negative 2 is definitely minus 6x. That's good. And then I've got minus 7 times by minus 2, which is positive 14. And it should be the case that the last numbers, they should all cancel out to give me 0. If I take away here, all of these here will cancel out to give me 0 and then 0, which means I'm finished. So I've now got this thing here, this is the same thing. So 3x cubed minus 4x squared minus 13x add 14 is identical, is the same thing as 3x minus 7, which is this linear factor, and then the quadratic, which I've just got on the top, x squared plus x minus 2. But it says work out this as, well, get the other two linear factors. I've got to factorise this here. If I factorise this, that's going to give me x plus 2 and then x minus 1. Okay, so this is the same thing as these three linear factors. Okay, so the answer is just going to be this, x minus 1 and then x plus 2. These are my other two linear factors. Right, question number 10 is here. We've got this. 2x minus 3 is a factor of this polynomial. Solve this, so I've got to go and divide this into this and give all solutions as exact values. Because it's asking for exact values, this means there's going to be some sort of square roots in the answer, which means the quadratic won't factorise. So at some point, I know, and it will make sense later, I've got to use the quadratic formula, which is given by this here. Okay, so I've got to use this quadratic formula at some point in the question. Okay, we'll come on to that bit in a second. Right, let's work through this. I'm going to go and do 2x minus 3 into this up here. So 6x cubed minus 25x squared plus 28x and then minus 6. Let's begin. So again, 2x times by something is 6x cubed. It's going to be 3x squared up here. Okay, so it's going to be 6x cubed again down here. And I go and do negative 3 times by 3x squared is minus 9x squared. And I perform my subtraction over here. That will give me 0. Minus 25 minus minus 9 is minus 16 x squared, and I bring down the 28x should be there, sorry. Okay, so plus 28x, and then 2x times by something is minus 16x squared, must be minus 8x. So 2x times by minus 8x is minus 16 x squared, and I've got to go and do negative 3 times by negative 8x, which is positive 24x. If I take these away, that's going to give me 4x down here. I bring down this minus 6 over here, so 4x minus 6, and I go and do 2x times by something is positive 4x, can be plus 2, and then I go and do negative 3 times by 2, good, so that's going to go to 4x, will give me minus 6. If I take these away also, everything cancels out to give me 0, which is good. So I'm kind of halfway through the question now. Now this here doesn't factorise nicely, which is where the exact value part comes in. So what I'm going to go and do now is to factorise this here, not to factorise it, to solve it because it's equal to 0. I've got to find the x values. I've got to put this into the quadratic formula. But actually, right, I can give one solution already because 2x minus 3 is a factor. So if this is a factor, I'm saying that, to make it really clear, right, what I've done here is, well, this is going to be equal to 0. That's one of the factors, so I can go and solve this. So 2x minus 3 is 0. Add the 3, divide by 2. X is going to be equal to 3 over 2. This is one of the factors. Okay, that's one of the 3 over 2. But now, to factorise this one and to solve it, I've got to put it into the quadratic formula. So we can see that A is 3, B is minus 8, and C is 2. So A is going to be equal to... In fact, if you're year 10, you wouldn't have been taught the quadratic formula just yet. It's just where you've got a quadratic in the usual form, ax squared plus bx plus c. If you can't factorise it normally, you put in the values of A, which for us is equal to 3, B is minus 8, and C is 2, and you put it into this quadratic formula, and it solves and gives you the solutions. So if we work through this, x is going to be equal to minus b, so 8, because it's minus minus 8, plus or minus the square root of b squared, so minus 8 squared minus 4 times a, which is 3, times c, which is 2, and that's all being divided by 2 times a, so it's all being divided by 2, multiplied by 3. So x is going to be equal to 8 plus or minus the square root of 64 positive. 4 times 3 times 2 is minus 24. And that's all going to be divided by 2 times 3, which is 6. So x is equal to 8 plus or minus the square root of 40 over 6. Now actually, this one I can go further again. Now year 10, if you've not been taught surds, you won't know this, but root 40, you can actually break it down, because root 40 is the same thing as root 4 multiplied by 10, because 4 times 10 is 40, and root 4 is 2, so 2 times by root 10. So this is actually the same thing as 8 plus or minus 2 root 10, all being divided by 6. Okay, now either that's going to be two solutions here. I've got 2 parts here to this. I'm going to be getting x is equal to 8, either plus 2 root 10 over 6, and I can simplify this, as you'll see in a second, or it's going to give me 8 minus 2 root 10, so a minus 2 root 10 over 6. Now this I can simplify, because I can see that 8, 2 and 6, they've all got common factors of 2, so I can divide everything here by 2, and if I do that, that's going to give me 4 plus root 10 4 plus root 10 over, and 6 divided by 2 gives me 3, or I've got this one, 4 minus root 10, if I divide everything by 2, over 3. Looking at the mark scheme, that is absolutely correct. You could split this up into 2 parts. You could write it as 4 over 3 plus root 10 over 3, but that's the same thing as this. So my other 2 solutions are going to be, and you can just write it if you want to, it's just 4 plus or minus root 10 over 3, because this plus or minus is giving me this solution and this solution. Okay, that's number 10. Number 11. Right, we're on to the binomial expansion, it looks like. Let's have a look at this question, which says the following. The expansions of this and this, they have the same coefficient. That means the same number before the x squared part. Work out the value of 8. So what you want to really go and do here is expand the first few parts here until you get to x squared, and then compare some coefficients. If we look at the first bracket, okay, so 1 plus 12x to the 4. Now to do these, let's consider Pascal's triangle. Let's go and do it over here. So we begin at 1, then go to 1, 1, then go to 1, 2, 1, 1, 3, 3, 1. So this is called Pascal's triangle again, guys. 1, 4, 6, 4, 1. And we only need this because we know that this first row of the triangle, we call it row 0. That's row 1. That's row 2. That's row 3. This is row 4. So if we're expanding to the power of 4, the numbers that I want in Pascal's triangle are going to be 1, 4, 6, 4, 1. So if I've got 1 plus 12x to the power of 4, it's going to make the pen a bit lighter. The numbers we've got are going to be 1 plus 4 plus 6 plus 4 plus 1. And then with the expansion of Pascal's triangle and binomial expansion, this is going to be the A part, that's going to be the B part, isn't it? Because we're always looking at this. It's always A plus B to a power. So A for us is 1. And I'm going to go and put 1 in here. And you begin with the biggest power of 4, and you keep reducing it by 1 every time. So 4, 3, 2, 1, and then 0. And then the b part for us is 12x. So in here, I'm going to write 12x, and it begins at 0. And then you go up by 1 for this one. So you go this, and you go this. Now, I can be a bit crafty here. I only want, in the question, the coefficient of x squared. I'm just looking at the x squared part. So I only want this part here. I don't have to go any further. That's all I want. If I just look at this a bit more closely, I've got, well, 12 squared is 144, times that by 6. 144 times by 6, let's quickly work it out. 144 times it by 6 is going to give me 24 there, 24 again, 26, and then 8 gives me 864. So 864 x squared. Okay. Right, that's fine. This is good. And you'll notice on this one here, a plus 4x cubed, if I consider this one down here, if I consider a plus 4x cubed, right, again, well, this one, I'm looking at cubing it, so I want row 3. So my numbers from Pascal's triangle are going to be 1, 3, 3, 1. So plus 1, plus 3, plus 3, plus 1. I won't need all of this, but then I go and put in the a part. It just happens to be a again, so I'm going to replace that with a to the 3, then goes down by 1, so a squared, a 1, and then a 0. The b part for us is 4x, so we're going to put in 4x, and then it goes from 0, and you keep increasing it by 1, and then 4x squared, and then 4x cubed. But you only want, again, the x squared part, so you just want this part here, x squared. So I'm just wanting this bit here. If I look at this bit in more detail, well, 4 squared is 16, times it by 3 gives me 48. So that's going to go to 48. The a is still there, so 48 times a times by x squared. So if they've got the same coefficient, if this here and this got the same coefficient, that means that we can compare this part, the a64, must be the same as this part here. It must be the same. They've got the same coefficient. So it must be the case that a64 must be equal to 48a. Okay, now to get a, I've got a simple equation here. If I divide by 48, if I go and do 864, if I go and do 864, and I divide it by 48, that's going to give me the a value what I want, which is going to be 18, and that is the answer. Okay. Good. Question number 12. Last one, number 12. Is this one here, n plus 2 cubed minus this, give your answer in a quadratic form. That's what this means, where a, b, and c are integers. Now, truthfully, you could use the binomial expansion here to expand this, but actually it's quite a small power 3. You could just, because actually this is GCSE maths, to be honest, you could just expand the bracket 3 times, which is actually what I'm going to go and do here. So let's consider this first part, n plus 2 cubed over here. That just simply means n plus 2 times n plus 2 times n plus 2. Now if I consider the first 2 times, okay, I'm going to use FOIL here to times these out. That's going to give me n squared. 2n twice will be plus 4n, and then 2 times 2 gives me plus 4. So I've got to go and do this, and then multiply this with the n plus 2 again. And again, we've got a FOIL here. I go and multiply this with this, the 4n with the n, and then the 2, and then the 4 times 2, and the 4 times by n and by 2. So this is going to give me n cubed, n squared times by n is n cubed, n squared times by 2 is 2n squared. I've then got 4n times by n, which is plus 4n squared. I've then got the 4n, I've got the 4n times by 2, which is 8n. I've then got the 4 times by the n, which is plus 4n. And I've got the 4 times by the 2, which is plus 8. And I can collect up some like terms here. I've got 2n squared and 4n squared. So overall I can bring this together to give me n cubed plus 6n squared. That will give me plus 12n, and plus 8 on the end. Good. And then I've got to go and just consider the second part, which is this over here. Minus n squared bracket n minus 5. That one's really easy to consider, really. I'm just saying I've got this. I've got minus n squared bracket n minus 5. Expand the brackets. Minus n squared times by n is minus n cubed. I've then got minus n squared times by negative 5 will be positive 5n squared. So now, if I bring all of this together, this gave me this, and this, including that negative, gave me this. Let's write it as one line. So altogether, I've got n cubed plus 6n squared plus 12n plus 8 minus n cubed plus 5n squared. Now, hopefully, things will cancel out a little bit here, and they do because, well, this n cubed and this minus n cubed, that will go to 0 because they're just opposite signs. I've then got, what else have I got? I've got 6n squared, add 5n squared, that's positive. Sorry, that's going to be positive 11n squared. I've then got just the plus 12n there, and I've got just a plus 8 on the end, and that's going to be the answer, hopefully. So 11n squared plus 12n plus 8, and you can see it's in the correct form. A for me is 11, B for me is plus 12, and C is plus 8. And looking at the mark scheme, that is correct. And that's the end, guys. That is it. Now, this is a bit of a long video to record. Hopefully it was useful. I'd really appreciate it, guys, if you could drop it a like, maybe share it around any friends or anyone that you might know that they might find it useful. Yeah, that is it. Any questions, of course, please comment in the comment section below. I will mark your papers ready for next term, and I'm really excited by this course, guys. When you first do the questions for further maths, it's going to be difficult because it's a step up, but I'm telling you, with a bit of practice and exposure to the exam questions, you can become very good, actually pretty quickly. It's just about practice. You guys are very, very good. We can become really good, and I'm really excited for you guys. Keep up the good work. Hopefully this was useful, and keep working, guys. Well done.